Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, peaks in an array. The problem is very standard application of segment trees. If you are someone who can solve the problem without the second query and don't know how to solve it with second query, it means you don't understand segment trees. And in that case, you can skip this video, and there is a complete series on segment trees in this channel. You can go watch at least the first two videos, and I'm very sure you will be able to understand how to approach the problem, how to approach this particular problem and solve it by yourself. But if you are someone who are not able to dissect the problem itself, I'm very sure by the end of the video you will be able to learn at least one new thing and solve the problem by yourself. So with that, let's get started. The problem states that you are given an array, and the peak of an array is an element that is greater than its previous and the next element in the array. And you are also given some of the queries. The queries are of two types. First, where you need to determine the count of peak elements in the subarray L to R. And second query is of type change the value of nums of index I to value of I, right? So this is updating a particular index. This is asking for how many peak elements are there in a range L to R. So you have to return the answer containing the result of all the queries of first order, right? So let's take an example. Let's say the array is 414215, right? And first query is 224. So the query is of type 2, which basically says we need to update the value of the given index to the given value. So the value of index 2, we need to update it to 4. So index 2 is already 4. So this query is basically a no op. Now second query is 102. This is of the type first. Basically we need to figure out how many peak elements are there in the range 0 to 2. So if you look at 0 to 2, there is no peak element, because if you look at the first element, there is no element before it, so it cannot be the peak element. If you look at the second element, there is an element before it, but the element is not smaller than the current element, so this element can also not be a peak element. Finally, for this 4, again there is an element before this, and this is indeed greater than the previous element, but there is no element afterwards, so this can't be peak as well. So there are no peak element among these three indexes, and hence the answer for first query is 0. Now for the second one, 104, you need to figure out how many peak elements are there in the range 0 to 4. So again, this can't be peak. We know this can't be peak because it is smaller than the previous element. This is now a peak. Why? Because we know that it's already larger than the previous element, and there is a next element as well, and it is greater than the next element as well. So this is, we found one peak element. Now this can't be peak element because this is smaller than the previous element. And finally this can't be peak element as well because there is no next element at all. So overall, in this subarray 0 to 4, we found just one peak element, and hence the answer here is found, right? So hope the problem statement is clear. Now how to solve this? As we mentioned, we'll first assume that there are no updates at all. Basically we assume that there is no queries of type 2. We only have queries of type 1, which basically says given L and R, give me the count of peak elements in that range. And we will try to solve this particular part first, and once this is clear, I think the next part would automatically be very clear. So we have three queries here, 150524. I didn't add the type because there's just one query type, and this basically says how many peak elements are there in the range 1 to 5. So this is talking about this particular range. So similarly, second query talks about 0, 5, third query talks about 2, 4. You need to count the number of peak elements for each of them and return that as an answer. So what's the brute force way to solve this problem? The brute force way would be for each element, for each query, you simply iterate over the array, figure out the count of peak element and store it, right? So if you look at 1,5, what you will do, you will start with 1, you'll say is this a peak element? The answer will be no, because there is no previous element at all. And you'll say is this a peak element? In this case answer would be yes, because this element is greater than the previous and the next element as well, so this is indeed a peak element. Similarly, you'll say this is this a peak element? Answer is again no, because this is smaller than the previous element. Is this a peak element? Answer is yes, because this is larger than the previous element and larger than the next element as well, so this is also a peak element. And finally, is this a peak element? The answer is no, because there is no next element at all, right? So we found that there are 2 peak elements in the range 1 to 5, right? Similarly, we will do the same thing for 0, 5. So for 0, 5, the range that is being talked about is the complete array. So we'll say is this the peak element? The answer is no, because there is no previous element at all. Is this peak element? Answer is again no, because even though there is a previous element, but this element is smaller than the previous element, right? Is this a peak element? Answer this time is yes, again, because this is greater than the previous one and greater than the next one as well, so this is indeed a peak element. And if you keep on doing this, you will see this is also a peak element, and finally this, you will say this is not a peak element, and you will stop. So do you see some like, if you do this entire thing, first of all, like, what's the time complexity? The time complexity would simply be number of queries multiplied by n, because for each query, in worst case, you can end up iterating over all the elements, right? So q into n is not efficient, because the number of queries and number of elements in the array is both 10 power 5, right? So we need to optimize this. Now obviously you can't remove q, you have to iterate over each of the query and answer them. So only thing you can optimize here is somehow reduce the query cost itself. So let's think about it. Between these two, do you see repetitions? So if you think for 3, you, for this query as well, you asked is this a peak element? For this query as well, you asked is this a peak element? Does anything change for this index? Answer is no. Does anything change for this index? Again no. And similarly, there is nothing changed for this index as well, and this is nothing changed for this index as well. Now this index undergoes changes. Why? Because previously in 1, 5, this index doesn't have a previous element at all, so it can't be a peak element for sure. But in the second query 0, 5, this element has a previous element, so it can be one of the possible peak element if other criteria are satisfied, right? So that's the only change. So if just one element is undergoing changes, why are you recomputing everything? Why not just compute this particular index and say is this a peak element or not? And if the answer is yes or no, based on that you can either add or subtract 1 from your previous answer, right? So this works here. Now will this work in 2, 4? The answer is you can't just subtract from the previous answer, because 2, 4 is now not a superset of the previous query. So you can't simply use the previous answer and work on to find out the next answer. You need to do something better here. Again, for 2, 4 as well, you will be asking the same questions to 3 and 4, right? And you will be getting the exact same answer. So there is a way to optimize thing, but the way is not that you can work with the previous result. Instead, what you can do is you can ask the question beforehand for each of the indexes. So you can say is this a peak element? Answer is no, this is not, because there is nothing before it, right? Is this a peak element? Answer is no, because this is smaller than the previous element. and so on and so forth. So basically one of the thing you can do is you can simply maintain a array where you will say whether an element is a peak element or not based on the entire array, right? So for 1 you are considering that 1 has a previous element, but in the query it may not have, right? Because in the query 1,5 it may be possible that 1 doesn't have a previous element, right? But for now what you're doing for simplicity, you are answering this question for every index as it is. So this is not a peak element because there is nothing before. This is not a peak element because the previous one is actually greater. This is a peak element and this is a peak element. So these two are 1, rest are 0, right? Now for this query 1,5, can you simply take the sum of this range and get the answer? Answer is yes. You had the answer was 2, and you can see if you sum up everything here you will get 2 only. But is this always true? The answer is actually no, because if you look at 2,4, if you sum up these things you will get 2, but if you actually figure out the value at 2,4, let's try to calculate the value of 2,4. Is this a peak element? Answer is no, because there is nothing before it. Is this a peak element? Answer is no, because it is smaller than the previous element. Is this a peak element? It is greater than the previous element, but there is no next element, so it is not a peak element. So basically the answer is 0 here, but from your array you will get 2. And why? Because you considered 1 for these two things, but they are not actually 1, they will be 0, because in the subarray where 2 is the starting point, it can never be 1, right? So I would strongly encourage you to pause here and try to think by yourself what should be the step forward to optimize the solution, because there's just one simple observation here which can optimize the solution. So hope you thought about it. The answer is, you know that for 2,4 everything will remain same except the first and the last element. And what will change for first and the last element is the fact that they can never be 1. So if they were already 1, you will not consider it, you will consider them as 0. In other words, instead of taking the sum in the range L to R, you can take the sum in the range L plus 1 to R minus 1, and that will for sure give you the correct result. Why? Because everything else, for everything, so you have L and R, right? So for everything in between, there's nothing changing, right? But for this L, if it was 1, then it will be 0. For this R, if it was 1, then it will be 0. So basically for this L and this R, you are not getting any contribution at all, right? And everything in between will stay the same, because for this element, the previous and the next element is not changing, right? And because of this fact, you can simply ignore L and R and just simply take the sum in the range L plus 1 to R minus 1, and that will give you the correct result. So let's just quickly verify this in the current example 1,5. So you can simply take the sum in the range 2,4. So if you take the sum in the range 2,4, this will be 1 plus 0 plus 1, which is 2. So this is correct. 0,5, again you will take the sum in the range 1,4, and if you take the sum in the range 1,4, again 0 plus 1 plus 0 plus 1 will be 2. Finally 2,4, you will take the sum in the range 3,3, and this will be 0, and you also have a value of 0, right? So hope this entire thing is clear. Now what is the overall time complexity? You have q queries. For each query, what you are doing, you first of all, this array you prepared beforehand, so that will take you order and time, right? After that, you are answering each of the query, and for each query you are taking a sum in the range L plus 1 to R minus 1, and that will, if you do it naively, that will take you order and time as well, right? So you haven't improved anything. But if you think about it, this sum, you can optimize it very easily to order 1, because taking a sum in a range can be done easily using prefix sum, right? So what you can do, you can simply maintain a prefix sum for this particular array and answer this query that what is the sum in the range L plus 1 to R minus 1 in order 1 time. So this will simply be order 1, and the complexity would simply be Q plus N, right? So hope this entire solution is clear. Now for those who don't understand prefix sum, it's simply you are taking the sum starting from the first index. So this index denotes what is the sum in the range 0 up till this index. Similarly, this index denotes what is the sum from 0 up till this index. Now if you want a sum in the range L to R, what you can do, you can take this value will denote you what is the sum in this range, right? And you can take this value will denote what is the sum in this range, and you can subtract these two to get what is the sum in this range, because when you subtract, this thing will cancel out with each other and only this thing will remain, which is what you want, right? So this entire thing, prefix sum as well, you can compute in order and time beforehand, and this will be your overall complexity, which is sufficient to pass the given time constraint. Now we solved this entire problem without query 2. Now what is the case when there are updates? So for example, instead of just having these queries, you also have update queries. This update query basically says, the black ones are update queries, which basically says update the value of index 1 to value 5. Similarly, this says update the value of index 4 to value 9. Now how to solve this? Can you apply the same trick? The answer is no. Why? Because if you apply the same trick, let's say you created this whether the particular element is peak or not, and you created the prefix sum. Now first query you can answer easily in order 1 time, that's fine. For second query 1, 5, this has changed to 5. Sorry, this has changed to 5. Now as soon as this changed to 5, this value will now be a peak element. So this will no longer be 0, instead it will be 1, right? Similarly, this one is now not a peak element. Previously it was, but now it is not. So this one is also changed to 0, right? Now because of this, will prefix sum, like what happens with your prefix sum? Prefix sum will change as well, and this can change drastically. How? Because this element, what this element was denoting, everything in the range 0 to 4, right? So anything here changes will change this element as well. Similarly, anything before 5, if anything changes, this 5 will be affected as well. So basically, if you change this element, all of these prefix sum needs to be updated. Similarly, if you change this element, all of this prefix sum needs to be updated. So what you're doing, you are changing this element and this element, and as a result of that, in worst case, all of these will be affected. In current scenario, it's easier because the net effective of this change is actually 0. So you can simply make it 1 and simply make it 0, and rest of the things can stay same. But overall, this has tendency to impact all the elements afterwards, right? And because of this, update query can take us order and time, right? And even though we are able to answer the range queries efficiently, update query will take you the largest time, and that will make the complexity equals to the brute force one, which was q into n, right? So we need to optimize the update queries as well if you want to go ahead with this route. And this is a very standard problem. Basically, you have an array, you want a range sum, and you also want update functionality as well. So that's what any range query data structure will give you. So you can simply maintain this array in a segment tree or maybe Pendrick tree, and whenever index is updated, just go and update the index in the segment tree. and range query in segment tree is also order login. So I will not be discussing about the segment tree in this video. You can watch the first video and the second video in this series to get that understanding. But overall, you can answer range updates and queries both in login time, and there are few number of queries, so the overall complexity will simply be q login. Now notice that update will be changing, or update has a tendency to change these three elements together, right, in worst case. So in if you are updating anything, you need to do 3 updates at max. So instead of 1 login, it will be 3 login for a one particular update, but the complexity, overall complexity, would still be within the limit. So the value of n is value of q is 10 power 5, so this will still be within the limit. If you have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself. If you don't know about segment tree, you can simply copy paste the segment tree structure from this solution and try to code this entire thing by yourself. So segment tree structure contains 3 things: update and query. You can simply call update with the position and the value, and simply call query with the left and the right index, and it will give you update will update the index, and query will actually give you the range query in that range. So you can use segment tree as a black box and try to code the rest of the things by yourself, so that you at least understand this particular problem. If you know about segment tree or have watched this video, I would strongly encourage you to code the segment tree part as well by yourself. So with that, next we'll be looking at the code, but I would strongly encourage you to at least try once by yourself before moving forward. So the code is very straightforward. So segment tree part, I'm not going into details. That's the standard range query, like segment tree with the range sum. For the actual function, what we are doing, we are simply figuring out whether each of the index is a peak or not. So this value function just takes in the index and will give you whether the index is a peak element or not. So we are updating the every index whether that index is peak or not. Basically, we are kind of building this initial array for us. Now once this is done, we will go over all the queries. Now there can be 2 types of query: either it is an update query or it is a range query. So for update query, we will go over the index, update the value. After updating the value, we know that at max 3 index can be affected, so we will simply check the values of these 3 index again, and whatever is the value we'll get, we'll simply update it, right? And after that, for the query of type 1 or range query, we simply check whether L and R, like whether you have to figure out the sum in between L plus 1 and R minus 1. So the first check is whether, like, if L plus 1 and R minus 1, if you do, whether there is still something existed or not. So for example, if L is this and R is this, you are sure that the value would be 0, because L plus 1 and R minus 1 doesn't exist at all. So this is the base scenario which you're checking, where we know that answer will be 0. For all of the scenario, we are simply doing a range query in the range L plus 1 and R minus 1, right? So hope this entire solution is clear. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.